Welcome back to Hyra Deep Dive. In previous deep dives, we explored what Hyra Network is and the outstanding advantages of this Layer 3 compared to previous generations of blockchains. Today, we will not only open the door, but also go straight into the central control room of Hyra Network, its consensus mechanism. This is a complex topic, but also a key factor determining the performance, security, and sustainability of any decentralized network. Imagine a large city where millions of transactions occur every second. To keep everything running smoothly without a central government, there needs to be an implicit system of rules ensuring everyone trusts the same data record. In the blockchain world, that is the role of the consensus mechanism. From the hard labor of proof of work, POW, to the democratization of proof of stake, POS, each mechanism is a philosophy on how to achieve consensus. But when we talk about Layer 3, a specialized layer designed for heavy tasks like AI and DePIN, the requirements for speed, efficiency, and scalability become extremely stringent. Can a traditional consensus mechanism meet these demands? Hyra Network says no. That's why they have refined and combined principles to create a unique heartbeat, optimized for the future. In this video, we will not only explain Hyra's consensus mechanism in an easy-to-understand way, but also dissect every technical detail, analyze its components, compare it with popular mechanisms, and explain why it is the key for Hyra Network to achieve the performance and reliability needed for a new era of decentralized AI and physical infrastructure, classification and limitations of traditional consensus mechanisms. To evaluate Hyra's superiority, we need to understand the current context more deeply. OMIS, proof of work. POW, safe but inefficient. O, how it works. Miners compete to solve cryptographic puzzles, hashes. The first to find the solution creates a new block and receives a reward. O, advantages. High security, censorship resistance, theoretically decentralized. O, disadvantages. DC, slow speeds, huge energy consumption, low transaction throughput, TPS, high latency, volatile transaction costs, not suitable for speed-demanding applications like AI. O, challenges of POW in modern Web3. Cannot scale to meet the needs of billions of IoT devices or complex AI models. Proof of stake, POS, towards energy efficiency. O, how it works. Validators are chosen to create blocks based on the amount of tokens they stake, lock, and other factors, stake age, randomness. O, advantages. More energy efficient than POW, higher TPS, lower costs. O, disadvantages. Concerns about wealth centralization, nothing at stake problem, requiring complex penalty mechanisms. Still not fully optimized for ultra-high throughput applications. O, POS variants. Delegated proof of stake. DPoS. Token holders vote for a small number of delegates to validate. Very fast, but risks power centralization in the hands of few delegates. Bonded proof of stake, BPoS. Validators must commit larger assets, often with slashing penalties if violated. Dissecting Hyra Network's consensus mechanism, the intersection of performance and security, Hyra does not just copy an existing mechanism. They synthesize and refine the best elements to create a hybrid consensus mechanism, specially designed for Layer 3's goals: ultra-high performance and AI DePIN integration. Foundation: Optimized DPoS for speed and efficiency. O, Hyra builds on the principles of DPoS to achieve high transaction throughput and low latency. A set of elected validators is responsible for validation and block creation. O, technical details. Discussion on validator election mechanisms can be based on Hyra stake amount, reputation, or a combination of factors to encourage broad participation and prevent manipulation. O, benefits for AI DePIN. Fast confirmation speed is crucial for AI applications requiring instant feedback, and for DePIN devices continuously sending small data packets. Enhanced security layer, Byzantine Fault Tolerance, BFT, and instant finality. This is the key point where Hyra outperforms regular DPoS. BFT is a property ensuring that a network can reach consensus even if a certain portion of nodes are malicious or unreliable. How BFT is integrated. Although specific technical details may be Hyra's intellectual property, BFT mechanisms typically include multi-round voting protocols. Validators conduct multiple voting rounds to ensure all reliable nodes agree on the same state. Commitment schemes. Validators must commit to a data block before it is finally confirmed. Economic finality. Once a transaction is BFT confirmed, it is considered instantly final without waiting for deep block confirmations like PO. Role of BFT in Hyra ensures that despite the network's high speed, AI data and DePIN transactions remain tightly secured against Sybil attacks or validator fraud. Incentive and slashing mechanisms. To ensure validators act honestly and efficiently, Hyra has mechanisms. Rewards. Validators earn Hyra tokens for successfully creating blocks and validating transactions. Slashing. If a validator misbehaves, e.g., tries to create invalid blocks, goes offline, part of their stake is slashed as a strong deterrent. Importance. These mechanisms are core to maintaining network integrity and decentralization long-term, stateless design, and cross-layer interoperability. Hyra's consensus mechanism is also optimized to operate as a Layer 3, meaning it can anchor its state to underlying Layer 1, Layer 2, e.g., Ethereum or Ethereum Layer 2. Explanation. Complex AI DePIN transactions are processed and confirmed instantly on Hyra's Layer 3, then only aggregated state proofs are periodically submitted to Layer 2, Layer 1. This significantly reduces the burden on base layers. In-depth comparison. Why does Hyra stand out? Let's put Hyra's consensus mechanism side by side with competitors to see the differences clearly. Hyra versus POW, Bitcoin. Speed and cost. Hyra is vastly superior in transaction speed and cost. Energy. Thousands of times more energy efficient. Applications. Hyra supports complex smart contracts and AI integration that POW cannot. Hyra versus POS, Ethereum 2.0. Specialization. Ethereum 2.0 is a general-purpose POS. Hyra is a POS, BFT specialized for AI and DePIN. This allows deeper architectural optimization for heavy computational tasks. Throughput. Hyra has potential for higher throughput for specialized tasks due to Layer 3 structure and refined consensus. Finality. Although Ethereum 2.0 also offers fast finality, Hyra focuses on near-instant finality for AI DePIN microtransactions directly on Layer 3. Hyra versus pure DPoS, EOS, Tyrion. Security and decentralization. Hyra enhances security and reduces centralization risks by integrating stronger BFT principles. Pure DPoS can be vulnerable to manipulation by a few delegates. Fault tolerance. Hyra's BFT makes the network more reliable even with malicious validators. Hyra versus optimistic rollups, Jekyll rollups, Layer 2. Rollups are excellent Layer 2 solutions for scaling Layer 1. However, Hyra is Layer 3, which can be built on top of those rollups. Specialization. While rollups scale general transactions, Hyra optimizes for specific AI and DePIN tasks, further reducing costs and latency for these workloads. Architectural optimization. As Layer 3, Hyra can have a more flexibly tuned architecture to fit AI DePIN requirements, which Layer 2 sometimes is limited by Layer 1 dependency. As we have seen, Hyra Network's consensus mechanism is not a random combination. It is a strategic, sophisticated design that addresses inherent challenges of previous blockchain generations and opens a new era. By leveraging DPoS advantages for speed and efficiency, while reinforcing with BFT principles to ensure security and instant finality, Hyra has created a heartbeat suited to the most demanding AI and DePIN applications. It's not just about processing more transactions, but handling complex, resource-intensive, and time-sensitive transactions that current Layer 1 and Layer 2 struggle with. Hyra Network's consensus mechanism is not only an impressive technical detail, it is the solid foundation for Hyra's vision of a decentralized future where AI can learn, grow, and serve humanity transparently, fairly, and without limits. This is why Hyra Network is not just another blockchain project, but a crucial piece in the overall Web3 puzzle. If you found this video helpful and want to continue diving deep into Hyra Network's technical analyses, don't forget to like, share this video, and subscribe to the Hyra Deep Dive channel so you won't miss valuable upcoming content. See you in the next video.